Today we're going to talk about standard form for linear equations. By the end of this video, you should be able to identify if a line is horizontal, vertical, increasing, or decreasing, and you should be able to graph linear equations in standard form by finding the X and Y intercepts. First, let's look at a few vocabulary words. A linear equation is an equation whose graph is a line. Most of what we do in Algebra 1 will be graphing lines. There are four main types of lines: horizontal lines, vertical lines, increasing lines, and decreasing lines. We've already talked about increasing and decreasing, so you should be familiar with those. Make sure that you remember horizontal goes left and right, vertical goes up and down. Standard form of a linear equation is in this format, where a, b, and c are all numbers. So you have a number times x plus a number times y equals a number. We can graph linear equations in standard form by finding the x and y intercepts. So as a review, remember that x-intercepts are where the graph touches or crosses the x-axis, and those points will be written x, comma, y, where y is 0. Y-intercepts are where the graph crosses or touches the y-axis, and that point will be 0, comma, y. Let's take a look at a few examples. First, we have 5x plus 2y equals 10. We need to find the x and y intercepts. Let's take a look at the previous slide, and we notice that for x-intercepts, the y value is always 0. So, if we want to find the x-intercept of this equation, we need to put 0 in for y. And then we just solve for x. 2 times 0 is 0, so this just gives us 5x equals 10. Then we divide both sides by 5. We get x equals 2. So our x-intercept is 2, 0. If I graph that, that is this point here. To find the y-intercept, if we go back and look, for y-intercepts, our x value is always 0. So I'm going to take 0 and plug that in for x. And then I solve for y. 5 times 0 is 0, so I just have 2y equals 10. Then I divide by 2, and I get y equals 5. So my y-intercept is the point 0, 5. If I graph that point, that is right here at the top of our graph. So to graph this line, all I need to do is connect these 2 points. Now, if we look at this graph, is it horizontal, vertical, increasing, or decreasing? If we start on the left and follow the line, we are going down, so this line is decreasing. Let's look at this next example. Again, we're going to find the x and y intercepts. But this time, I'm going to show you a shortcut. If we go back to the first example and look, when we plug 0 in for y, this whole y term becomes 0. So, the shortcut to find the x-intercept is to cross out the y term and then solve that equation that you're left with. So if I solve negative x equals negative 4, Now this is the same as negative 1x, so I'm going to divide by negative 1, and I get x equals 4. So my x-intercept is 4, 0. That is this point here. To find the y-intercept, I'm going to cross out the x term, and I have 4y equals negative 4, and then I solve. So I divide both sides by 4, and I get y equals negative 1. So my y-intercept is 0, negative 1, which is this point here. Then I just connect the points. Now, is this line horizontal, vertical, increasing, or decreasing? If we start on the left and follow the line, we are going up, so the line is increasing. If you are confused by this shortcut, you don't have to do it. You can do this problem the long way by plugging in 0 for x and y. Our third example is the equation y equals 4. This means that the y value is always 4. The x value could be anything. So we want to name several points where our y value is 4. So you can pick anything you want for the x values. I'm going to pick ones that I know will fit on this graph. So you could choose 1, you could choose negative 1, you could choose 4, you could choose negative 3, you could choose 0, and remember the y value is always 4. You could choose 2, and then the y value is always 4. You can pick any number you want for x. Now I'm going to plot these points. So I have 1, 4, negative 1, 4, 4, 4, negative 3, 4, 0, 4, and 2, 4. And you can see that these are forming a straight line. So all I need to do is connect these points with a line. And this type of line is a horizontal line. Now I'm going to write down my x and y intercepts to show you something. Does this graph have an x-intercept? No, it never touches the x-axis. So I'm going to put none. Does this graph have a y-intercept? Yes, and that point is here at 0, 4. So every time you have an equation that is just y equals a number, you're going to end up with a horizontal line. And horizontal lines have no x-intercept, but they do have a y-intercept. Our fourth example is the equation x equals 1. This means that the x value is always 1. The y value could be anything, so we're going to name some points where the x value is 1. We can pick anything we want for the y value. So I'm going to pick negative 2, positive 2, negative 3, positive 5. Then since my x is always 1, I have 1, 0, 1, negative 1. You can pick any number you want for y. And then I'm going to plot these points. 1, negative 2, 1, positive 2, 1, negative 3, 1, 5, 1, 0, and 1, negative 1. You can see that these points form a straight line, so we can connect the points, and then we have our graph. This type of graph is a vertical line. Let's write down our x and y intercepts. We do have an x-intercept, and that is this point here, which is 1, 0. But we do not have a y-intercept. This line never touches the y-axis. So we say there is none. Anytime you have an equation that is x equals a number, you will get a vertical line, and that line will have an x-intercept, but no y-intercept. Lastly, I want you to try this problem on your own. So pause the video, find the x and y intercepts, and then graph them. And I'll give you the answer in a minute. So here is our graph for this equation. Our x-intercept is -3, 0. Our y-intercept is 0, 5. When you plot those points and connect them, you get this increasing line.